Hello. The soft copying techniques. The continuation to last presentation it is special networks. We are the part of special networks. Okay, let us share my I will share my screen. Just 1 minute. The sharing. The probabilistic neural net we discussed in the last presentation. Cascade correlation network also discussed in the last presentation. This is combination network, neuro combination network. Those things also we discussed already in the last class. We will start from cellular neural network. This is the continuation topic. Exactly from the last class continuation. Cellular neural network is exactly a starting topic for the last class. Continuation to last class, what I want to say is cellular neural network is already introduced in 1988 only. It is based on cellular automata. Every cell in a network connected to its neighbor cells. Figure A and B shows 2 by 2 cellular networks, 3 by 3 cellular networks respectively. The basic unit of a cellular network in a cell, okay, in a figure as shown in figure below, 1 by 1, 1 by 2, 2 by 1, 2 by 2, they are matrices actually. Like 1 comma 1, 1 5, 1 3 are first column, first row, first column. Okay, first row, second column, like that. The matrix, this is a matrix way of division. Like 1 2, 1 3, 2 1, 2 2, 2 3, 3 1, 3 2, 3 3, they are matrix way of making the arrangements in the block diagram. All are just like as matrix arrangements. Okay, the cells are not directly connected with each other once we observe the diagram. They affect each other indirectly due to propagation effects of the network dynamics. The cellular neural network can be implemented by means of hardware model. It is implemented by the use of hardware model. That is very important. This is achieved by replacing each cell with linear capacitors and resistors, linear and nonlinear control sources, independent sources. Is achieved by linear and nonlinear control sources, independent sources, resistors and capacitors. They are simple passive elements, of course. It's achieved very simply, of course, the cellular network is. Cellular network is a wide variety of applications. There are a lot of applications for the cellular network. For example, is image processing, pattern recognition, array computers. One of the application is image processing. Image processing, pattern recognition, array computers. These are the very famous applications for the cellular neural network. Today, in the practical field, of course, I am working on practically. That's why I am telling in a commanding. The neural networks has a lot of importance. If you want to implement any application based on the neural network, it has a lot of significance in the practical world. Without using neural networks, there is no significance at all. There is no significance at all at the coming into the practical applications. Optical neural network. The next continuation is optical neural network. Let us see about optical neural networks. Optical neural networks interconnect neurons with light beams. Owing to this interconnection, no insulation is required between signal paths and light rays and can pass through each other without interacting. Okay? The path of the signal travels in 3 dimensions. The transmission path density is limited by spacing of light sources, the divergence effect, and the spacing of detectors. As a result, all signals paths operate simultaneously, and true data or results are produced in holograms with high density. The weighted strength are stored. These stored weights can be modified during training for producing a fully adaptive system. There are two classes of these optical neural networks: electro-optical neural networks, holo-optical correlators. I'm explaining, okay? These points మనకి ఈజీగా దొరకవండి. ఒక్కొక్క పాయింట్ మీకు డెప్త్గా నీట్గా ఎక్స్ప్లెయిన్ చేస్తూ వస్తున్నాను నా ప్రాక్టికల్ ఎక్స్పీరియన్స్ని బట్టి, డిఫరెంట్ దాన్ అదర్స్. సో ఈ పాయింట్స్ కలెక్ట్ చేసుకోవడం మీకు చాలా డిఫికల్టీ. ప్రతి పాయింట్ మీకు సింపుల్గా ఈజీగా ఎక్కడ హర్రీ లేకుండా బర్రీ లేకుండా సో నీట్గా మీకు ఎక్స్ప్లెయిన్ చేస్తూ వస్తుంది. ప్రతి పాయింట్కి కూడా లాట్ ఆఫ్ ఇంపార్టెన్స్ ఉంది. ఇవన్నీ కలెక్ట్ చేయడమే చాలా టఫ్ అని చెప్తున్నాను. ప్రాక్టికల్లీ వర్క్ చేస్తున్నాను కాబట్టి ఐఎమ్ టెలింగ్ ఇంట్రెస్టింగ్ పాయింట్స్ ఫర్ యూ. ఓకే, దీస్ ఆర్ ద క్లాసిఫికేషన్స్ ఆఫ్ ఆప్టికల్ న్యూరల్ నెట్వర్క్స్. ప్రాక్టికల్గా వీటన్నిటికీ చాలా ఇంపార్టెన్స్ ఉంటుందండి. ఓకే, అఫ్ కోర్స్ ఈచ్ వన్ హ్యాస్ ఇట్స్ ఓన్ అడ్వాంటేజెస్ యాజ్ వెల్ యాజ్ డిసడ్వాంటేజెస్. Coming into the practical aspects, electro-optical multipliers. Electro-optical multipliers, also called as electrical optical matrix multipliers. They are called electro-optical matrix multipliers. Perform matrix multiplications in parallel. That is electro-optical multiplier. The speed of the network is limited only by the available electro-optical components. Here the computation time is potentially in nanoseconds range. A model of electromagnetic multiplier is like this. This is the model. Just I want to enhance the diagram. Lens, light for the susceptible dose. Lens, light of the susceptible columns. Electro-optical amplifier. Figure shows multiply 9 elements of input vector by 9/7 matrix. Produce 7 elements in net vector. There exists a column of light sources that passes its rays through lens. Each light illuminates single row of white shield. The white shield is a photographic film where transmittance of each square is a proportional to the weight. There is another lens that focuses each column shield a corresponding photoelectron. Please try to understand. Okay, there are two lenses here. The one lens exists on the column of light sources, passes through the lens. Each light illuminates a single row of white shield. Another lens that focuses the light from each column of the shield in a corresponding photoelectron. Like that, there are two sets. It's a net equation. Okay, net I is the net output neuron K. Weight from the neuron I. The output of each photodetector represents the dot product between the input vector and A. As a matrix multiplication performed parallelly, the speed is independent of size of the array. Holographic correlators. This is another classification of the concept. Previously we discussed about the electro-optical multiplier, that is the different concept. Holographic correlators is a different concept. In holographic correlators, the reference images are stored in a thin hologram and are retrieved in a coherently illuminated feedback loop. The input signal, either noisy or incomplete, may be applied to the system and can simultaneously be correlated optically with all the stored reference images. These correlations can be threshold and are fed back to the input, where the strongest correlation reinforces the input image. The enhanced image passes around the loop repeatedly, which approaches the stored image more closely on each pass until the system gets stabilized on the desired image. The best performance of optical correlators is obtained when they are used for image recognition. Image recognition. General optical image recognition hologram system is shown in figure. Mirror A. Okay, I want to zoom this pinhole array. Mirror B, lens 2, lens 3, okay, first hologram, second hologram, lens 1, lens 4, laser beam will travel, inputs, beam splitter, threshold device like this. Optical image recognition. The system input is an image from a laser beam. This passes through a beam splitter, which sends it to the threshold device. The image is reflected, then gets reflected from the threshold device, passes back to the beam splitter, then goes to the lens 1, which makes it fall under the first hologram. There are several stored images in the first hologram. The image can get correlated with each stored image. This correlation produces a light patterns. The system of the beam, image from a laser beam. Just to understand the concept, this passes through a beam splitter. The system input from a laser beam passes through the beam splitter. It sends a threshold device. The image is reflected, then gets reflected from the threshold device, passes back to the beam splitter, then goes to the lens 1, which makes it fall on the first hologram. There are several stored images in the first hologram. The image then gets correlated with each stored image. This correlation produces light patterns. The brightness of the pattern varies with the degree of correlation. The projected images from lens 2 and a mirror A passes through pinhole array, where they are specially separated from this array. Light patterns go to mirror B through lens 3, and then I apply to the second hologram. Lens 4 and a mirror C then produce superposition of the multiple correlated images onto the backside of the threshold device. The front surface of the threshold device reflects most strongly the patterns, which is the brightest on its rear surface. Its rear surfaces as projected on it the set of 4 correlations of each 4 stored images. With the input image, the stored image that is similar to the input image process highest correlation. This reflected image again passes through beam splitter and recenters the loop for further enhancement. The system gets converged on the stored pattern, most likely the input pattern. The next concept is third generation neural networks. This is the next concept. Spiking neural networks is the first concept here. As it well known, the biological nervous system has inspired the development of the artificial neural network models. On looking into the depth of working of biological neurons, it is noted that working of these neurons and their computations are performed in temporal domain, and the neuron firing depends on the timing between the spikes simulated in the neurons of the brain. These fundamental biological understandings of the neuron operation lead the pathway to the development of spiking neural networks. In short, it is called SNN. SNN falls under the category of third generation neural networks. And this is more closely related to the biological counterparts compared to the first and second generation neural networks. These developed spiking neural networks are transient pulses for performing the computations and require communications within the layers of the network design. There exist different spiking neural models, and their classification is based on the level of abstraction. Architecture of the spiking neural network. First show in observe the diagram. The membrane's potential is increased and the time of the membrane's potential reaches threshold so that spike is emitted. Just examine the spikes in the diagram. In the diagram you should observe. Neurons in central nervous system communicate using short duration of electrical impulses called spikes or action potentials in which their amplitude is constant in the same structure of neurons. These offer biological past third generation neural connectionist model. They derive their strength and interest from an accurate modeling of a synaptic new interactions between neurons, taking into account on the time of spike emission, overcome computational power of neural networks made of the threshold or sigmoidal units based on dynamics, event-driven processing. They open up new horizons for developing models within the exceptional capacity of memorizing and a strong ability to faster adaptation. Add a new dimension, temporal axis, to the representation, capacity, and processing abilities of neural networks. There are many different models one could use to model both the individual spiking neurons and also the nonlinear dynamics of the system. Neurons communicate with spikes and also known as action potentials. Since all spikes are identical, basically a neuron is divided into three parts. Okay. Generally speaking, dentities, soma, and axon are the three parts. The dentities receives the input signals from the previous neurons. The received input signals are processed in the soma, and the output signals are transmitted at the axon. The synapse is between every two neurons. If neuron J sends a signal across the synapse to the neuron. The neuron that sends a signal is called presynaptic neuron. A neuron receives the signal is called postsynaptic neuron. I want to post these two keywords. Presynaptic neuron. Postsynaptic neuron. Every neuron is surrounded by positive and negative ions. The inner surface of the members, there is an excess of negative charges. In the outer surface, there is an excess of positive charges. This is also a very important word about inner and outer surfaces. Those charges create a membrane potential. Each spiking neuron is characterized by membrane potential. When the membrane potential reaches a critical value, it is called threshold. It emits an action potential known as spike. A neuron is said to fire when its membrane potential reaches a specified threshold. When it fires, it sends a spike towards all other connected neurons. Its membrane potential then reset and the neuron cannot fire short period of time. The output of spiking neuron is therefore binary, but it can be converted to a continuous signal over time. Activity of neuron over a short period line is connected to mean firing rate. The spikes are identical to each other and their form does not change. The signal moves from presynaptic to postsynaptic neuron. The firing time of neuron is called spike time. Just observe the spikes. I already shown you before diagrams in the spikes. How they are. Just examine the diagram. One of the neuron model technique. The parameter describes time scale of recovery value mu. Smaller result in a slower recovery. The parameter B describes. Observe the to understand this. Observe these equations. These two equations, V dash and U dash. Just first examine those two equations. Okay, on that equations, parameter A describes time scale of recovery variable U. The parameter B describes sensitivity of the recovery variable U. Parameter C describes after a spike reset value of a membrane's potential V caused by the fast high threshold K. Parameter D describes after spike reset over the recovery variable U. Suppose we take our previous network concept into here. Just now explain that concept. supervised learning network. You can apply the concept here. Supervised learning concept. I want to apply our continuation presentation. This is the concept of spiking neural network concept also, SNN. The short called, it is called spiking neural network concept. ఓకే ఇక్కడ లింక్ చూడండి ఎంత జాగ్రత్తగా చూస్ చేసుకోవాలో. నేను ఒక్కొక్క పాయింట్ అందుకే మీకు ఎక్కడ దొరకని పాయింట్స్ అని చెప్తూ వస్తున్నాను నాలెడ్జ్గా. ప్రతి పాయింట్కి బ్యాక్ సైడ్ లింక్ ఉంటుంది, అందుకే నేను అవన్నీ గో త్రూ చేస్తూ మీకు రిఫరెన్సెస్ పెడుతూ వస్తున్నాను. ఎవ్రీ పాయింట్ హ్యాస్ ఏ లింక్ ఫర్ ద ప్రీవియస్ టాపిక్స్. ఇక్కడ అలాగే మనకి లింక్స్ వస్తున్నాయి నెక్స్ట్ అల్గారిథం బుల్ చేసేటప్పుడు కానీ, నెక్స్ట్ కాన్సెప్ట్స్ చదివేటప్పుడు కానీ. వీఆర్ గెటింగ్ దట్ మచ్ ఆఫ్ కాన్సెప్ట్స్, ప్రీవియస్ కాన్సెప్ట్స్ లింక్స్ ఆర్ గెటింగ్. ఓకే, the concept of spiking neural network concept here. Spiking neural network concept. Spiking neural network with n neurons is assumed fully connected to the output. Each neuron I is connected to every other neuron. The synaptic strength of these connections given by n by n matrix, where Wi, j is the strength between the output of neuron j and input of the neuron I. Wi represents synapses of the input neuron. Wj represents synapses values connected to the output neuron j. It uses two-dimensional data. It is used as random input for each neuron n, 0, n, and 0, 1. 0 mean and unit variance. N 0, 1 stands for 0 mean and 1 variance. Encoding of neurons in SNN. Spiking neural network can encode digital. Again, the backend concept is required. Digital and analog information. The neural coding schemes are of three categories: rate coding, temporal coding, and population coding. There are three categories of neural coding schemes. Neural coding schemes are of three types. There are three types: rate coding, temporal coding, and population coding. They are called techniques of neural coding. Neural coding. They are techniques of neural coding. They are under classification, of course. In rate coding, the information is encoded to the mean firing rate of the neuron. It is also known as temporal average. In temporal coding, the information is encoded in the form of spike times. In population coding, a number of input neurons are involved in the analog encoding, and this produces different firing times. Commonly used encoding method is the population-based encoding. In population encoding, analog input values are represented into spike times. using population coding. Multiple Gaussian descriptive fields are used so that the input neurons encode an input value to the spike times. The firing time is computed based on the intersection of Gaussian function. See the formulas here, that's enough. Mu formula and sigma formula. After formula, the important concept is learning with spiking neurons. Similar to other supervised learning algorithms, the synaptic weights of the network are adjusted iteratively in order to impose a desired input-output mapping to the SNN. Learning is performed through implementation of synaptic plasticity and exactly synapses. The synaptic weights of the model, which are directly connected to the input pattern, determines the firing rate of the neurons. This means that carry learning phase generates the desired behavior by adjusting the synaptic weights of the neuron. The neuron characterizes sudden change of membrane potential instantaneously prior to the subsequent to the firing. A potential behavior feature leads to complexity in training. See, SNN method has how much it is importance it is. That's why I revised previous concepts based on SNN twice. Some of the learning models, spike based supervised learning model, spike time dependent plasticity, neurons can be trained to classify categories of input signals based on only temporal configuration of spikes. The decision is communicated by emitting precisely timed spike trains associated with which give input categories. Trained neurons can perform classification tasks exactly. The weights between presynaptic neuron and postsynaptic neuron do not have fixed values. It has been proved that experiments that can they change and this affect the amplitude and the generated spike. The procedure of the weight update is called learning process, and it can be divided into two categories: supervised and unsupervised learning. If the synaptic strength is increased, then it is a long-term potential. If the strength is decreased, it is called long-term depression. Long-term penetration, okay, potentiation and long-term depression. Both are important words. LTP. It is called LTP. Both word has an importance. Spike prop algorithm, learning algorithm. SSN employs spiking neurons as computation units, which account to precise firing times of neurons for information coding. The information retrieval from the spike trains are done by binary bit coding, which is a population coding approach. This section presents error back propagation, supervised learning algorithm employed in the spiking neural networks. Each SSN is a set of neurons. Input neuron, output neuron. For each non-input neuron with threshold function, potential, each synapse, a response function, weight, the structure of neuron tend to be fully connected feed of a forward network. Formally, a spike train is defined a sequence of pulses. The firing of time of neuron is denoted as t, where f is equal to 1, comma 2, 3. Just observe that equation. Direct function dou of x is equal to 0 for x not equal to 0. For integration words, it is for minus infinity to infinity dou of x dx equal to 1. The objective of the train, the desired target firing, and the actual firing times. The least mean square error function is chosen. In error back propagation algorithm, each synaptic terminal is taken as a separate connection. Spike probe algorithm. The threshold is chosen and the weights are initialized randomly between 0 and 1. In step 2, a feed forward stage. Each input synapse receives input signal and transmit to the next neuron. Perform the error back propagation learning process for all the layers. The equations are transformed to the partial derivatives and the process is carried out. Calculate dou j using actual and desired firing. Time of each output neuron. In step 5, calculate dou. In step 6, update weights. In step 7, compute new weight is equal to old weight plus delta Wij. For hidden layer, calculate the each change in weight. Compute new weight in hidden layer. New weight, old weight, Wik. Spike time dependent plasticity. Stop learning. Spike time independent plasticity is used a more quantitative form of deep learning method. It emphasizes the importance of causality in synaptic and pre-synaptic spike produces post-synaptic spike by tens of milliseconds, then synaptic efficiency is increased. This is important concept. Note this concept. I want to post in the chat box. When the postsynaptic spikes produces presynaptic spikes and the synaptic strength decreases. Furthermore, the synaptic efficiency is a function of spike times of presynaptic and postsynaptic neurons. This is called spike time independent plasticity. The well-known algorithm is shown in below. This is the equations you can observe clearly. Delta W and W mu. Conventional neural networks. Conventional neural network is built up one of the more number of conventional layers. And after it is trailed by one or more fully connected layers like feed-forward networks. CNN architecture is designed processes the structure of two-dimensional input image. That is CNN's key advantage is that this consists of images and this is representation of images designs the architecture in a practical way. The neurons are arranged in three-dimensional height, width and depth The neurons are arranged in 3-dimensional. In what way? Height, width, and depth. That is the logic. The logic we have to follow is height, weight, and depth. This is the logic. Coming to neuron, the information penetrating to depth is an activation volume and represent third dimension. The architecture of designed carried out with local connections and possesses weight, and which are subsequently followed by contain operations. Figure shows, you can observe the diagram. Input layer, and hidden layer 2, depth, width, height you observe in the diagram. Just see the diagram very clearly. Arrangement of neurons in a CNN model. Okay, just examine the diagram. The information penetrating depth is activation volume and it represents third dimension. The architecture designed with local connections and possesses weights which are subsequently followed by the certain pooling operations. CNNs can be trained in an easy manner, and these have minimal parameters. Some number of hidden layer creates that the other fully interconnected networks is made up of layers. Each and every layer has transform of 3D volume into an output 3D volume along certain differences with or without any parameters. Layers in coming convolution networks. Convolution layer, pooling layer, fully interconnected layer. Layers in convolution networks. This is the you note down this one. In depth, I will discuss in the next presentation in the next class. Because you should be to make a grip as a well-wisher. I am telling up to this. Then I will discuss about these things in the next coming presentation. I want to stop here. Just see the concepts up to this as a well-wisher. I am telling. Next class, I will explain these layers of convolution neural networks. Okay, right. I will post some of concepts to you also. Okay.